Hello and welcome to this channel. In this video I'm going to provide a solution to physics 214 2020-2021 past question. So the first question says that you should state the Newton's law of universal gravitation. So you have to state the law normally as it is given in the material. So the force of attraction between two bodies of mass m1 and m2 is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So that's all for the first one. So and hence, obtain the net gravitational force that acts on particle 1. So this is the particle 1 due to the other particles in the figure 2. So here the figure is given, shows if the figure 2 shows an arrangement of 3 particles with particle 1 having mass 6.0 kg. So this first particle 1 is having 6 kg and particle 2 and 3 having the same mass 4 kg. This one is having mass 4 kg with distance A equal to centimeter. So as you can see, the distance between the first mass and the second mass is A, while that of the third mass and the second mass is 2A. So what that implies is that whatever the distance between these two guys is, the distance between those guys two is times 2 of the distance between this M2 and M1. So we can withdraw this to be M2, M1, M3. So because A is equal to 2 centimeter, so it means that this distance will be 2 times A, which is 4 centimeter. So we are asked to find the net force, on this particle. So as given by the Newton's law of gravitation or universal gravitation, there will be force of attraction between this M1 and this M2. Equally, there will be force of attraction between this and this one as well. Now we have to find the net force. So if the force of attraction is between this and this in this direction, and also between this and this in this direction, then the object will be moving in this direction like that. So let us try and do that. So we have the first one. Okay, so this is the M1 and this is the M2, M3 from the question. So M2 is having 4 kg. This is also having 4 kg and this is having 6 kg. This is 2 centimeter and this is 4 centimeter. So you have to find the force of attraction between this and this. So and the force of attraction between these two guys will be G M1 M2 over R squared. So that will be G times M1 is 4 times M2 is 6. Sorry, M1 is 6, M2 is 4. Then over R squared. Now your R must be in meter. So because you're having 2 centimeter here, it will be equal to 2 divided by 100. That will be 0.02 meter. So you have 0.02 square. So your G is a constant. So you have to press that. It's not given, so you have to know it off. And so when you press this in calculator, we have shift constant. So if you want to get the value for that in calculator, it is at number 39. So and it gives 6.67 times 10 raised to the power minus 11 times times 4 times 6 divided by 0.02 squared. So this gives the force to be 0.000004 Newton. So that's the force of attraction between these two guys. Now you calculate for between this and this one as well. So if you want to do that, it will still be G 4 times 6 over, now your R here is going to be 0.04 meter. So that will be 0.04 squared. So and if you calculate that, that is going to be G, okay, which is times 4 times 6 divided by 0.04 squared. So this gives 0.000001 Newton. So that means we can still redraw it again, that the force that this is being attracted with is 0.000004, and in this direction it is 0.000001. Now to find the net force, you can use the parallelogram law of forces to find that, because this is going to be your resultant force. So if you use parallelogram law of forces, this side will be equal to this side. Okay, so which means this side too will be 0.000004 Newton. So you can just bring out this triangle here. Okay, then you can find your resultant force like that, and that is going to be by using the Pythagoras theorem. Okay, so r square will be equal to 0.000004 square plus 0.000001 square. So your answer will be r equal the square root of whatever you get here. Okay, you find the square root. Your answer in Newton, that's going to be the answer for the first question. So that's how you go about that. Now for the second question, you're asked to obtain the force field of the following potential function. So if you want to obtain the force field of a potential function, the way you go about that is, remember, your force field F is related to the potential function with by this formula d of your potential function dr. Generally it's actually d, okay, dv over dr, but because the r also is a position vector, so it can be x, y, and z, so you just have to split it. So it's going to be minus, okay, in bracket of I d dx v plus j d dy v plus k d dz v. So that is how you find your force. So you have to find for I, j, and k. So it's going to be minus, so you have to find for that. So your v for the first one is x square plus xy plus xz. So that's your v for the first one. V equal x square plus xy plus xz. So you have to find the derivative of this with respect to x, the partial derivative. So it's going to be d dx of v, and v here is x squared plus xy plus xz, and that is going to be, when you differentiate with respect to x, you have 2x plus y plus z. You still have to do with respect to y for that. So, and if you do that, the force will turn to 0 because it's a constant. This will have x, and this become 0 as well. So your answer is basically x. For the last one, d dz of x squared plus xy plus xz. That is going to be, with respect to z, all this will become 0 and you have just x. So your answer will now be I d dx of v is, in brackets, 2x plus y plus z plus j d dy of v is x plus k d dz of v is also x. So that's going to be your force. The force field for this potential function will be given by this. So that's how to find that. Use the same method for the second and the third one as well. So for the second one, we have ax y square z cube. Ax y square z cube. So your v is ax y square z cube. So your force will still remain minus in bracket of I d dx v plus d dy v. I mean it will be j, okay, plus k d dz v. So you find d dx of v, which is ax y square z cube. That will be with respect to x, that was going to be ay squared z cube. D dy with respect to y in this case, so that's going to be 2axy z cube, because it's going to be, when you differentiate this, it's like ax z cube then the y square. Then when you differentiate this one will be treated as constant. We have ax z cube times 2y. That's the differentiation of that. So you now have 2, okay, and you arrange like that. So that's how you go about that. Then with respect to z, d dz of ax y squared z cube will become, you treat all these ones as constant and you differentiate this, that's going to be 3z square. So we have 3 ax y square z square, and your force will become minus I. With respect to x, you got ay square z cube plus j, you got 2ax y z cube plus k 3ax y square z square. So that is going to be your force for the second potential function. Now for the last potential function xyz, you did the same step, okay. So your potential function is xyz. Your force will still be minus d dx of v I plus j d dy v plus k d dz v. So d dx of v, which is xyz, will become yz. D dy of xyz will become xz, and d dz of xyz will become just xy. So your force will now become minus I in bracket of yz, okay, plus j xz plus k xy. That's going to be your force. Now to this third question, the C part. All you have to do here is that, look at the question. It says that a light spring is found to stretch by an amount b when it supports a block of mass m. So initially it will have a particular natural length. So let's say this is the spring. It will have a particular length initially. Let's represent that with a. Okay, now when it supports a mass m, it is stretched, okay, by b. So let's say this is the mass m and this is the natural position, but after you put your mass m, it is stretched by b. So this length a is b. So let's look at that. Okay, so if the block is pulled down a distance L from its equilibrium position and released at time t equals 0, obtain the resulting motion as a function of time. So they still stretch it even further downward by a distance L. So it means that this is the equilibrium position. Now, as it is in the equilibrium position, it means that this will be the length as it is it won't go up any longer. So it means that it will retain this particular length. But the weight of this object, mg, will be equal to the k times b, which is the Hooke's law, the force as given by the Hooke's law. So which is the restoring force. The force that wants to restore it back to this position will be equal to the weight of this object. So that is what will keep it in this particular position. But the moment you still even pull it down further, okay, now you pull it down further, this is the equilibrium position now, but you pull it further by a particular length L. Remember, this will now be the sum of the natural length and this one, so that will be A plus B. Okay, then this L. So when you do this, what you have next is this. According to Hooke's law, the restoring force will be minus K B plus L. The force that wants to restore it back to its initial position will be, when you add, it'll be minus K, then plus the total extension from here, okay, from here to this place, because this part is B and this part is L. So that's why we have it here. Normally the force is equal to KE. So the restoring force will be this. And the reason we are putting the negative is that the restoring force is actually going back. It is in opposite direction to the displacement, because as you are displacing it downward, the restoring force will be facing up. It will be trying to restore it, in its original position. So the restoring force, now if you want to find the net force, the F net, it will be equal to, when the weight is acting downward, which is mg. So when you now subtract the restoring force, the force that's trying to restore it back, which is kb plus L, this is going to give you your net force. And the net force is mass times acceleration. Generally, that's for force. Will be equal to mass times gravity minus kb plus L. Okay, and it will be m times acceleration equal mg minus kb minus kl. Now don't forget, at equilibrium mg is equal to kb. Okay, so mg and kb are the same. So when you subtract this from this, because they are the same, you get 0. So you now have ma equal minus kl. And from here, what you can do is that you can have ma plus kl to be equal 0. Okay, now you can divide both sides by m. So we have divided by m by m by m. So m will cancel m. We have a equal, sorry, it won't be equal, it will be plus. A plus k over m L equal 0. Remember that omega equals square root of k over m, because you might say that this omega is for the simple harmonic motion, but it's still the same thing here, because the mass will still keep oscillating at the moment that you draw it at a particular length L. So it will keep oscillating. So this is very similar to simple harmonic motion. So we can have this W, which is the omega, to be equal to square root of k over L. And from here we can have A to be equal to, sorry, again it will be plus, not equal to. So that will be, now if you want to express k over m now, you can square both sides. So when you square both sides, this will become omega square equal k over m, and we have omega square L equal 0. All right, so now when you look at this A can be expressed as d dt of velocity, okay, because acceleration is change in velocity with respect to time, plus omega square L equal 0. So velocity itself is actually the change in displacement with respect to time, plus omega square L equals 0. So we have d square of x over dt square plus omega square L equals 0. So this equation is actually the second order differential equation. And when you solve this, it has a general formula. So the general formula for this second order differential equation is x as a function of time equal C1 cos omega t plus C2 sine omega t. And some people might still be written as this equal a sine omega t plus 5. So this is the general equation for that reaction, and this is what you're asked to find in that question. So you might just simplify it further at t equals 0 and you get your answer, but this is the general equation that you're supposed to get. So that's going to be the end for that first question. Now for the second question, a body of mass m mass 6 kg moving at this speed eastward. So let's just start analyzing it one after the other. So this mass m, let me try and get rid of this. So mass m of 6 kg moving at this speed eastward. So remember, if you want to draw the 4 cardinal direction, that will be north, some. So this is how you draw it. So this mass, okay, which is 6 kg, is moving in this direction at a speed of 5 meters per second eastward. Collide with another body of mass 12 kg moving at the speed of 3 meters per second northward. So northward is in this direction. So another object is moving in this direction northward with speed of 3 meters per second, and it is 12 kilograms. Now, if after the collision, the body stick together and move at 60 degrees northeast. So the meaning is that after these guys collide, they move together northeast. Look at this. When you say northeast, it means in this direction. And it's what? 60 degrees northeast. That is 60 degrees from the north towards the east. So it means that they are moving in this direction. Okay, and to the vertical, which will be the north, it is 60 degrees. So this is the angle through which the two guys are actually moving. Then we are asked to find their common velocity. So how will you find the common velocity in this case? Now, because this velocity, if you look at that, the direction is actually is neither horizontal nor vertical. So it is at an angle, and it means that it's going to have vertical and horizontal components. So what you have to do here is that you have to find the horizontal component of this velocity and the vertical component of this velocity. Then if you are able to find out, it's going to be in this direction, like vertical, horizontal, and from there you can get the value in this direction like that, which is actually going to be r square equal the velocity you get in vertical square plus the velocity you get in horizontal square as well. So that's how you can get your velocity. So now it means that we have to analyze this problem according to their plane. So it's going to be in two plane, x and y plane. So you still use the normal conservation of linear momentum, which is going to be m1 for the first object, u1 plus m2 u2 equal m1 v1 plus m2 v2. But from the question, we were told that they stick together after collision. Look at that. They said if after the collision, the two bodies stick together and move at this. So the point is that they move together after collision. So it means that they will have the same final velocity. So in this case, we don't need to, we can start from there actually, because the velocity of the first object and that of the second object are the same after collision. We have m1 u1 plus m2 u2 equal m1 v, let's represent that with v, plus m2 v, the common velocity. So you can factorize v out and we have m1 plus m2 v equal m1 u1 plus m2 u2. So this is the formula we're going to use, and you're going to calculate the velocity in two planes, for x and for y. Now let's start. If you want to do for this first object, let's say we want to start for x component, x component. Okay, the x component of the velocity is going to be, the first mass is 6 kilogram times its initial velocity in x-axis is actually 3 meters. Is this 3 or 5? This should be 5. Let me check. So from the question, it is actually 5 meters per second. So that will be 5 times 5 plus m2 is 12 kg. Now in this direction, that is in x direction, it doesn't have any velocity. It's actually moving up. So the velocity will be 0 equal m1 is 6 plus m2 is 12 times the common velocity. So this will become 30 equal 18v. And from here, the v will be 30 over 18, which will become, when you divide that, you have 30 over 18. So that will become 1.67 meters per second. So that's our Vx equal 1.67 meters per second. So let's do for y component. Okay, for y component. So for y component, we're still going to use the same formula, but in this case, we're going to consider the y velocity. So the first mass is still 6 times the velocity in y component. So it doesn't have any velocity in y component, it's only moving in x component. So the velocity will become 0 plus m2 is 12 times the velocity in vertical component will become 3 equal m1 is 6 plus m2 is 12 times the velocity. Don't forget this velocity is now the common velocity in y component. So this becomes 0 and we have 36 equal 18v. So v becomes 36 over 18, and that's going to be 2 meters per second. So vy equal 2 meters per second. Then we can get our velocity like that. So since the object will stick together and move in this direction, okay, our x and y, these are vy and these are vx. So if you want to find that, that's going to be the way we did it the other time. We're going to use the Pythagoras theorem to solve that. V squared will become vx squared plus vy squared. So that will be v squared equal, vx squared is 1.67 squared plus 2 squared. So v will become the square root of 1.67 square plus 4. So, and at the end, we have v to be equal square root of, so when you find this in calculator, square plus 4, then you find the square root of your answer, you have v to be equal to 2.6 meters per second. So that's how you get your velocity for that question. Now, this next question says that 3 bodies of masses 2, 3, 4 respectively are placed at the corner of an equilateral triangle 2 meters apart from each other. Determine the center of mass. All right. So for an equilateral triangle, it means that they have equal length. The 3 sides are equal. That's just the meaning. And if you draw an equilateral triangle, say for instance this, it is not really perfect, but just manage it. So these 3 corners, we place our masses there, the 3 masses, and there are 2, 3, and 4. So I may put my 2 kilogram here, my 3 kilogram here, and my 4 kilogram here. And we are told that 2 meters apart from each other. So it means that each of them are 2 meters apart from each other. That is, the length of their side is 2 meters. 2 meter and 2 meter. So you have to find your center of mass. So the formula you will use is that the summation of mass times the distance will give you, divided by the summation of the mass will give you the center of mass. Now when you start, if you choose this to be your reference point, okay, you have to do two things here. You have to find it in x and y components. That's how you find your center of mass. So from here, when you start from here, if this is your center of mass, if this is your reference point, you want to find your center of mass from here, you are going to say m1 x1 plus m2 x2 plus m3 x3. This is for x-axis over m1 plus m2 plus m3. So in this case, for the first mass, which is 2 kilogram, times its distance in x-axis will be 0 because it is actually at the origin. So along the x-axis, it is not at a particular distance from the origin, so it is 0. Then plus m2, which is 3 kg. That will be 3 times its distance from the origin is 2 meter. Then plus m3, which is 4 kg. Its distance, when you trace this down, okay, it should be half of this distance, so that's going to be 1. So from x-axis, this is 1 meter apart away from the x-axis, divided by m1 is 2 plus m2 is 3 plus m4 is m3 is 4. So this is going to give us 6 plus 4 over 5 plus 4, that is 9. So we have that to be 10 over 9. And don't forget, even by merely looking at this formula, mass will cancel mass. So your answer will be in meter. So, and that's going to be in x-axis. So when you divide this, 10 divided by 9 will give us 1.1 meter. Okay, so your coordinate for the center of mass will be 1.1, okay, meter for x. Now for y, you use the same formula. That will be, let me try and get rid of all this for y. So for y, you still start from here because this is choosing to be your reference point. So it will be m1 y1 plus m2 y2 plus m3 y3, all divided by m1 plus m2 plus m3. So this object, the first mass 2 times the distance in y-axis is 0 because it is not moving, it is actually exactly at that reference point, so that will be 0, plus m2 is 3 kg. Then some distance above this reference point along the y-axis is 0 as well. Okay, because it's actually exactly at that reference point. It's not moving up. It's not actually at a distance up from this reference point. Now plus 4, which is the third mass, times. So of course, this is actually at a particular distance, in the y-axis from the reference point. But mind you, it won't be 2 meter. The 2 meter is for the slant height. For this vertical height, you have to calculate it. So what you will do is that to find this height, name it x. So you can use this right angle triangle here to find it. So, this whole length here is 2 meters. So definitely this will be 1 meter and this part will be 1 meter. So this from here to here is actually 1 meter and this from here to here is what? 2 meter. So this will be the hypotenuse. One of these will be the opposite and the other will be the adjacent. So hypotenuse square, according to Pythagoras, will be equal to x squared plus 1 square. So we have 4 to be equal to x squared plus 1. So x squared will be equal to 4 minus 1 and x squared will be equal to 3. So x will be equal to square root of 3. So that will be your x. So we put it there. Mind you, it is not in x-axis, but we just represent the length, the distance from the reference point to that particular position of mass 3. Okay, we represent it with x. So your answer will be square root of 3. Then all divided by the total mass. My is 2 plus m2 is 3, m3 is 4. So at the end, this becomes 0, 0, and we have 4 root 3 all divided by 9. So 4 root 3 divided by 9, 4 root 3 divided by 9. So this gives 0.77 meter. So your y coordinate will become 0.77 meter. So this is going to be your center of mass. And what that implies is that when you draw the equilateral triangle, this is your 2 kilogram mass, 3 kilogram, and 4 kilogram mass. From this reference point, when you measure from here, let me use another ink. So from this x-axis, when you measure 1.1 meter and you get something around here, and from the y-axis as well, from the reference point, if you measure 0.77 to the y-axis, when you trace the two of them, okay, that point that you get inside the object is actually the location of your center of mass. So that is it for this video. I won't bother to go through all these ones. They are already in your notes. Just check them. Very straightforward. The way you are given in the notes, just give them back. So I just want to explain these technical parts, these tricky parts, all these calculations. So that's what this video seeks to explain. And that's it for this video. Thanks for watching. I do really appreciate. Please make sure you like this video. If you find it helpful, like the video, subscribe, and comment. Give us beautiful comments to help us promote this channel, and share with your friends as well. Thanks for watching, and I wish you the very best in your upcoming examination.